This video, we're going to determine the domain and range of an exponential function. And we're going to have the f of x equals ab to the x power. Alright, I just want to kind of explain this a little bit. A is actually what you start with. It's our starting number or our initial number. And b is our what I call our multiplier. It's our what it's being multiplied by. X is represented the time or intervals. Alright, and so that's basically how this is, and of course this is y. But we're being asked about the domain and range of this. Alright, so this is an exponential function. You can tell it's an exponential function because it's kind of like a parabola in some sort of way that's been kind of like decided to take a nap laying down. Alright, the green line never gets to, it'll get close to the x-axis, but it'll never touch the x-axis. There is an invisible wall here, and I'm going to put it in red here. When exponentials, they have what they call an invisible wall, and the invisible wall here is actually is on the x-axis. So I'm going to put a little dotted line on the x-axis. What we mean by the visible wall, just think about an invisible wall. If you were walking down a hallway or something, there's a visible wall there, you would run into it, but you really couldn't go past it. So once people know that it's there, they just kind of try to work their way around, and so they never actually touch this visible wall. And this visible wall is called an asymptote. There's a vertical one and a horizontal. This one's a horizontal. Alright? And so all these exponential functions have them. You could have two of them, one vertical and horizontal. And I think you can even, I have never experienced it, but I'm pretty sure you can have more than one horizontal asymptote or vertical asymptote. I'm thinking that's more of an algebra 2 concept. But anyway, in this situation, we are going to find the domain and range. So the domain, which is of course our x value. So we're looking at where our parabola on our x-axis, where does the drawing start and end? And you can see that exponentials have arrows, and so one keeps going up. So no matter how many times I go from the x-axis up to touch, it just keeps going in both directions. So again, this is one of those that's all real numbers, because all the numbers will touch it. Remember, this is also where you could actually write the word all real numbers. You could actually write negative infinity is less than x, which is less than positive infinity. You could write that as well. So for this purpose, I'll just leave it as the double bar symbol for all real numbers. For the range is the y-axis, where it starts and stops on the y-axis. So if you look at the y-axis, this actually goes on. I mean, every time I go to the y-axis and go to the left, or it'll touch it every time, and it's an arrow, so it keeps going up. So it never stops increasing on the y-axis. But look at your y-axis when it gets closer to 0. As it gets closer to 0, the line starts to flatten up. The exponential starts to flatten out. And when it starts to flatten out, it'll get closer and closer to 0, but it'll never touch 0. So remember what I said, it'll never touch it. So anytime you have an asymptote, it'll never touch that asymptote. It'll come close, but it won't. So in this case, we're going to say y is greater because everything above it is bigger than 0. We're not going to put an equal to because we can't touch 0. So we're going to put 0. And so this would be our range. We could also, like we've talked about before, I did that wrong. We could write the range like this. We always have to put the smaller one first, and the smaller one is 0. So it'd be 0 is less than y, which is less than positive infinity. That's another way you could write it. Alright, so here's another one, and I did this one so you could see what the with the, look, see what happens. Now if you notice, we have a horizontal asymptote, and it looks like it's right here. It's that invisible wall. And if you're asked what's the asymptote, you say 1, 2, 3, 4, 5. So it'd be when y equals 5. All right. So what's my domain? My domain is not going to change because it's still arrows and it's still going to be all real numbers. My range, however, is going to be a little different here because my asymptote is at 5. I know that it does not go higher than 5, but it does go lower. So I could say y is less than 5. Or we could say that negative infinity is let me erase this. I'm sorry. Is less, oh, I keep hitting the wrong one. Let me try it again. Negative infinity is less than y, which is less than 5. And so 5 is the biggest number that it'll go to. And that's how you do the exponential domain range.